morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll get to as many as we can near the end of today's webinar. And also at the end of today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards. So please stick around and wait for the drawing, and hopefully you'll be one of our 3 lucky winners. All right, with that, we will go ahead and kick off today's webinar, which is 7 techniques for ramping your DevSecOps program quickly. Our speaker today is Jake King, who is CEO and co-founder of Cmd. Hey, Jake, how are you?
How are we doing, Charlene? Great to chat. Thank you for your time.
Right. Well, thanks for joining me today. I know you have a great presentation on tap, so I'm going to put myself on mute and let you get right to it.
Thank you, Charlene. Thanks again for joining us today, folks. It's great to be able to go over some of the things that we've been learning over the last few years at Cmd, specifically as it pertains to DevOps and DevSecOps. A little bit about myself. I think it's important to cover a little bit of the background of the company, and where our kind of grounding came from. My background is specifically in defensive, essentially defensive security and information security management. And I started my career in information security specifically as a red teamer and a bug bounty pen tester in Perth in Western Australia. I've since moved to Canada to start, obviously, Cmd. And prior to starting Cmd, I worked as the lead security operations engineer for a company called Hootsuite, where we did a number of different innovations and integrations with our development team, and specifically took on a lot of the DevOps mentality very early on in our life cycle. We've been adding a lot of those kind of principles and procedures to Cmd for the last few years. And it's myself and my co-founder that have come up with a lot of the principles that we'll show you today, and obviously go into a little bit of detail in the back end. But first and foremost, I think what's really important to cover is really the DevOps cycle. Everybody on this call understands the principles behind DevOps and why we try and do the things we want to do, specifically around maintaining a solid build pipeline, getting our product out to market quickly, deploying that code safely, testing it effectively, and obviously releasing it in an efficient cycle. And DevOps is really about enabling a lot of these processes in a very seamless and efficient way. We look at operations and developers working together, and security really does love DevOps. The principle behind the paradigms behind DevOps are really what enables security to do their job well. And it's those paradigms that really provide us a good understanding of where things are at in production and what might be actually going on. One of the things that we always assume with DevOps is really clean, concise, defined infrastructure. And it's that infrastructure that we make a lot of assumptions around. We assume that our automatic build system is running efficiently, and we assume it's running on time. We assume that when we grab that build and push it into our CI or CD framework, we're able to see that move into production seamlessly without any effects. We're hoping that a lot of those post-deployment operations are 100% headless and hopefully even completely automated before it even hits that environment. We assume manual tasks that are occurring in the cloud after a deployment is run are automated through cloud service provider APIs, or even through some really basic controls that you can have built into different DevOps tools that we use every day. But realistically, when we look at the reality of what's going on within DevOps environments, not all these failure modes might be pertinent to your environment, but there's certainly things that we're seeing quite a lot of at Cmd. We've definitely seen a lot of manual restarts after a container's built or a service is made and kind of shipped to an environment. We've seen a lot of changes that are being made right last minute in a CI/CD pipeline process. And because of those last minute changes, we're often seeing QA run a few checks on hosts. from that point forward as well, we also see a lot of operational tasks being run in production. And unfortunately, these are certain factors of life. We'd love to minimize our interaction with systems, but the outlier cases are often the cases that we have to really dive into a little bit deeper and understand a little bit more about. And so really one of the questions we often find we're asking at CMD and our customers are asking of us is, how do we really know what's going on after we deploy an application? And when we're thinking about an application that's deployed, what's going on behind the scenes once it is shipped and once it is delivered? Well, to answer this question, we really need to look at runtime visibility and runtime controls that we can have. And as I go through the 7 steps that we're focusing on today in our webinar, we're not only going to be looking at the 7 major factors that we've identified as things you can do to move the needle, but we've kind of identified these 3 questions that lead into those 7 pointers quite well. You'll need to gain an insight into what automated processes are doing in your environment to really gain an understanding of what system baselines look like normally, what's actually going on in an environment. And developing that baseline is incredibly difficult to do unless you've got a pretty clear picture of what's going on in production after that application is shipped. Once we do deploy an application, it's really important that you track manual changes. If an engineer is logging in after a deployment's run, if an engineer is logging into a service that's persistent or consistent across your deployments to make a change or adjust a configuration, you need to track those changes and you need to understand what the changes were about. But you should also, now knowing what's changing and really kind of understanding a little bit of a baseline, really care about looking at unexpected patterns of behavior. And this isn't necessarily just a nice to have in a lot of the environments that we work with, a lot of the environments that we see. It's actually a mandate. And these mandates through security are actually very easy to implement if you can kind of follow some of the basic steps. But the panacea is to develop a solution that's end-to-end and very easy and very maintainable. But the thought that a lot of our teams have is if we add too much complexity, my developers will just find a way around. And this is really true. Complexity is absolutely difficult to maintain, especially when you add security controls to an environment that might already be complex on its own right. So how do we actually take this understanding and this better control and really understand how we can change behaviors without losing a lot of that DevOps advantage of really going to market quickly and shipping product in an efficient and an effective way? How can we make sure that we can enable a developer and a DevSecOps team to work together cohesively and understand the risks to the environment without overwhelming with complexity? Well, first and foremost, after you've deployed an application, we need to think about the runtime. We need to think about the application being deployed and shipped and the code being in a relatively static state. The underlying infrastructure running that code can change a lot. And we often find that a lot of organizations that are focused on monitoring and managing the application that's deployed or the software that's shipped often overlook the executions, the patterns of behavior, the changes that are being made on the host underneath that application itself. Changing an Nginx configuration can change the way your application is served to your customers. It's incredibly important to understand the commands or the outputs of those commands, even some of the network connections or manual or automated processes that are running to kind of complete tasks after the fact. I'm sure we've all been in a position where knowing exactly what was run on a host before it went down would be really helpful and insightful in identifying where that failure mode is. We also want to look at how the state changes of that system. Executions can change patterns of behavior, it can change different parameters, but they can often be used for simple troubleshooting or debugging. When we're actually making a stateful change to a system in production, it's really important we can understand and capture those changes in a way that's going to allow us to either revert the change or perhaps even go back to that change and understand what might have changed in the past. Compliance standards often mandate that we track changes in our environments. And the DevOps advantage is being able to ship an environment and understand that it's going to stay in a consistent state. If you've got any form of access, whether it be Cloud Shell access or SSH, even Docker API is exposed, you're at risk of having system files changed or potentially application files changed. But we also need to kind of consider that those files might contain very sensitive information. And that sensitive information could be something that you don't want to end up in a logging provider's console, or even in your Splunk or Sumo Logic consoles if you're recording to those environments. You've got to make sure that you're not capturing too much and not capturing too little. We've all been in a point where we've captured a parameter or a property as part of a web request in our web logging or in our application logs that exposed a little too much about what was going on in the environment at that particular time. Make sure that you're keeping a close eye on maintaining confidentiality and the privacy of the data that's on these systems. And as we start to get to that confidentiality and privacy, we've really got to understand the kind of people that are accessing these systems are our developers. We trust our developers, but adding constraints to identify who is doing what and why they're doing it is incredibly important. But understanding methods in which they can, access this fleet of systems in a safe and consistent way is also incredibly important. So covering and capturing methods of connecting to an infrastructure that don't just necessarily include SSH sessions. It could be API calls, it could be existing shells that are provided by your cloud service provider. Keeping accounts that are used for services to services and keeping accounts that are used for named usage, obviously fit for purpose. As we start to move from understanding a little bit about what's going on, it's about highlighting the events that we really truly care about. And this is not unexpected. Any developer that's deployed a fleet of systems or an application is going to monitor that application's performance. Any operations person is going to monitor the system's infrastructure state. And for security, it's looking at unusual or suspicious events. Now, this could be something as simple as a new binary being downloaded to a system and executed, which could be malware. It could also just simply be a development tool. But if we're looking at broader topics, it could actually be a pattern of behavior that's exhibiting a change in an environment that could potentially pose you or your infrastructure at a risk. So it's really creating alerts around really specific use cases or events that you care about, and relying on some industry standards to do this, to make sure that you're not capturing too much or too little, and to make sure you're looking at the things that matter to security professionals. Realistically, looking at those changes and getting the alerts is always amazing. But I think one of the biggest challenges that we find is once we've created a state change, or once we've looked at an alert, it's tracking and persisting that change in an environment where you can know it's been addressed. We've all been in a situation where we've made a change to a system, we've looked at an alert, we've seen that alert change, we've reverted that file system change, and now we don't know whether it's changed or not changed, or where that system state is actually at. When something interesting is happening, we need to look at flow control. We need to look at the ability to control the state of that execution and really understand the things that we can actually do to get in front of a change and record what state's actually occurring. And then finally, if you have the opportunity to, because a lot of us don't have a complete SOC team in our environments, work with your SOC. And if you don't have a SOC, start to build out some of the capabilities of the security operations center in your own tool set. We want to integrate standard security checks and a lot of the balances that we put in place to really get a good baseline of what's going on within our infrastructure, and not necessarily overlook a lot of the themes and a lot of the topics that a security team would really care about. In all, we're trying to keep adversaries out of our network. We're trying to keep our network operating in a consistent and efficient way. And without kind of maintaining and mandating a lot of the checks and balances that security teams like to bring in, we often find that it falls to the wayside. So going through those 7 major points, we've talked in a lot of generalities. We've talked about gaining a bit of insight. We've talked about capturing some changes and obviously mandating some privacy. We've looked at ways that we can kind of start to look and alert and notify on different behaviors and respond when things change on a system, and obviously work with different teams in your organizations. But often where this becomes a little bit more complex is when we start to look at the tapestry of tools that we have to combine to gain a lot of these feature sets. Linux in its own right, if you're shipping a Linux application, perhaps even a Docker container to a Kubernetes environment, contains some basic information in the default logs. It's going to contain some information about what's going on, where things are at, but it's probably not going to contain enough information for you to reconstruct an event. And a really great way to look at this is if you have had a change in your environment in the past, were you able to isolate and identify exactly what went wrong relatively quickly? As this is kind of a demonstration of a lot of these core principles, CMD designed and decided to build our system based on a lot of these principles. We wanted to look at the way that developers operated their infrastructure and built code. We wanted to look at the way that operations teams were working with developers to ship, deploy, and build a really consistent picture for a production environment. But we wanted to capture those extraneous use cases. We wanted to capture that arbitrary access. We wanted to look at QA accessing a system or making a change to a file and monitoring and maintaining that system state in a way that you could also identify security threats or potential risks without necessarily bringing in a cohort of multiple different tools. And we started to do this by integrating our platform with very industry standard vendors. Platforms like Slack or PagerDuty to notify you on some of that unusual behavior. Tools like Yubico and Duo keys to authorize activity in real time. And we even provided some integrations to JIRA and other ticket management systems to maintain and track the state of an action inside your environment. It keeps the compliance folks happy and it makes sure that you're tracking the changes effectively. And lastly, we added automation controls. Think the ability to block access to a file or optionally capture the output of a state of a system call simply by adding a policy in line with what's going on in your environment. And so I thought I'd use a little bit of today's session to not only cover a few of these major points, but I thought I'd cover a few of the components that make CMD so valuable. What I wanted to show you today is how CMD is built and how we obviously operate it within a DevOps environment, and how it can be used to gain a little bit of visibility into what files and execution activity is doing in your environment. We wanted to cover a little bit of the safe access and alerting, really where it actually matters. We don't want to be woken up at 3 a.m. on something that doesn't actually matter. It's about identifying who changed a state and showing you how we can map these behaviors for you and how to respond really effectively and automatically to any threat in your environment and potentially even capture some extraneous activity. So I'll jump straight into our demonstration. And for this demonstration, I'm going to be demonstrating our environment running on a Ubuntu 16.04 system running in GCP. GCP is our cloud provider of choice. However, any Linux instance running really in any environment can be leveraged with the software that we deploy. What you're seeing here is our access console to CMD. This is essentially the hub of where you can gain a bit of insight into what activity is going on within your environment without having to send your logs to costly systems like Sumo Logic or Splunk, just to gain a bit of insight into what developers are actually doing. We can see on the top left here, we've got a session count and our command count. This shows the volume of executions that are arbitrarily happening in this environment. There's a lot of changes being made. We can see the files, edits, and views by different users on our environment. And we can see some summaries of events and activities that we should really care about from a security perspective. Not only this, we've added some GeoIP information to really kind of show you where people are coming into your environment and how they start to modify, change states, or even kind of make changes for your environment by looking at where they're logging in from. This can be very useful to identify extraneous activities or potentially unusual behaviors from folks that might be accessing your fleet in a bit of an unusual way. We start with this console view, but we're able to very quickly dive down into some of the very detailed metrics. Looking at simple counts of events happening on the system is a good way to identify anomalies, and a number of the components in our system operate in that same way. But what we're able to do is very quickly dive deeply into the session information that's going on within a particular server. We talked about gaining a bit of access to files and what's going on within the file system of a particular server. And so what I've got displayed here is an engineer's access to one of the servers in our fleet. I've isolated this session by looking at a session identifier, and I found this session quite interesting because it was quite a diverse set of executions that were running. What we can see here is the engineer logged into a server using SSH. They were able to use sudo to privilege escalate a bash shell and run a series of commands to check the state of Nginx and actually kind of move some internal files and perhaps even make a quick stateful change to an HTML file. When we think about this as developers, it's especially kind of scary to think that our application might be changing after that application is deployed. But a quick change like this could be done very, very easily through a Cloud Shell, even native access if you have enabled it, and sometimes even through Docker containers through things like Docker exec or even Kubernetes control plane commands. But what we can see here is a quick summary of the events that we should look at and care about within this system. The system is tracking this information automatically. Once an agent's deployed, you get this level of visibility into any kind of system or process activity on the host, and you're able to dive deep into looking at the properties and permissions of every single attribute of that execution. In this case, we're tracking things like the process ID, where it was run from and how it was run. We're even able to track things like where the session was invoked from, what method of connection was used, and how many commands were run in that session. You can see that command count is actually much higher than we anticipate, and it's primarily because we're capturing every single exec underneath that shell at the same time. We're doing a lot of really powerful things to make sure that we're really understanding what's going on within the system and mapping a lot of that behavior and activity to exactly what's going on within the shell. We can not only see what's going on within the system, but we can see each of the execs and the commands that a user is potentially running. As we can see here, a netstat shell was invoked, and not only can we capture the command itself, but we can capture the output that was printed to the screen. This can be incredibly helpful when trying to debug or potentially look at information that may have changed on the system that might only be apparent by looking at the TTY. We came up with this solution primarily because a lot of the existing products on the market that provided some form of capability of tracking output were primarily focused on playback methodologies. And while it's exciting to watch a user run a couple of commands or tail a log file, it can get very tedious when trying to identify the risks that that person may have added to our environment. As we start to drive down these commands a little bit more, we can see a couple of different execs run to check the state of different systems, look at different execs and where different binaries are running on the system. But there's a couple of different executions in this highlighted session that become quite interesting. One of the things that we're able to do with our system, and it's primarily because of our agent-based vantage point, is not only capture the executions that a user was running, we're actually also able to capture the modified files or the system file changes that were actually operated by that user. In this case, we talked a little bit about that nginx state being checked, and I quickly noticed that an index file was modified, looking at the highlighted event here. The highlighted event is really marking an indicator of potential compromise or a stateful change in the system. What we're able to identify is that the user modified a particular string within this index file on our nginx server. And while this might seem pretty innocuous, we're actually able to see exactly what the user was able to perform. By hooking different properties inside of the file system and identifying different write and operations that are made via system calls from the shell, we're actually able to instrument and look at different modifications to a file. Now, you might be thinking you don't want to track this kind of operation for your application, and you're exactly right. We have the ability to very quickly filter and modify where we capture these file differences and what kind of things are going on within the system to make sure we're building a complete picture, but not capturing too much information. As we can see here, it's in a standard diff format, which makes it very easy for us to quickly look to see what an engineer has changed or potentially modified within that file. Lastly, we can see that nginx was reloaded. It's really important to note that not only most of these executions thus far have been standard kind of command line arguments, very simple command line switches. When we launch a different application or a service wrapper, we're also able to traverse deeply into the system to look at what's actually being run under the covers, what's actually being executed by the system. And this is incredibly helpful when an engineer may have aliased a different command, may have run a specific compiled binary, or maybe even running a tool that we don't actually know what's going on. Triggers, policies, and alerts really come into play as we start to look at this standard behavior. Adding a bit of color to this session really comes at your control. It's really important to understand that as we start to demonstrate some of this session information, we have the ability to not only see this detail as it comes through from the host, but we have the ability to mark different executions as interesting based on our policies. Policies are really difficult to construct. And as we all know, crafting and identifying what really matters to a security team, or potentially even going a little bit deeper into what's going on within an environment, how things are operating, or even why we've made a stateful change can be quite hard. It's also really difficult to understand what security teams are super excited about when you do deploy an application. And so at CMD, we've deployed a number of not only industry standard policies that help you align with standards such as SOC 2 or ISO, but we've also started to align our policy engine with very common attack matrix patterns. CMD leverages and contributes to quite a substantial amount of policies into our platform based on the MITRE ATT&CK standard. This is looking at adversarial indicators of compromise. And why this is so valuable is, given the restriction of the environments that we're talking about, we're not going to see a lot of flyby malware. We're definitely not going to see a huge amount of rootkits. And while our system is capable of detecting them, they become very, very much outliers to the kind of activity that you should be seeing in production. MITRE ATT&CK policies give us the ability to identify not only insider threats, but potential account compromises and different patterns of behavior. The platform ships with a set of default policies that we implement based on the MITRE ATT&CK trigger set and are tested against a number of different patterns of execution. These can be chosen to fully block, fully monitor, or simply alert. And the wonderful thing about our policy engine is any one of these triggers can be statefully changed to tweak to your environment or tune. We also have some deduplication and event logic to make sure that these aren't firing rapidly or unusually for your environment. We have the ability to not only display the event itself, but prioritize that event and where it tends to go to. We work with the systems that you want to be able to leverage to make sure that you're not getting inundated with simple emails or maybe even PagerDuty requests. These policies only invoke based on an action. What's incredibly important about a policy is having the ability to maintain and monitor state. And so as we start to look at these patterns of behavior in our environment, potentially a specific execution that might be modifying an etc host file to change a DNS parameter, or adding a user to a system or changing a user's permissions, become very interesting. We need to not only be alerted about these conditions, potentially through our tools of choice, but we also need to have case management and some resolution logic around this. Now in CMD, if you don't have a very comprehensive ticket management system that you're using very, very rapidly for your environment, or you don't want to pepper JIRA or your existing ServiceNow account with a number of different events, one of the things we've been able to provide inside our console is very easy case management. If an event occurs, not only are we able to look at the session itself to see the execs that the user was running and what that user might have been doing, we're able to resolve that state, leave notes about its state being changed, and we maintain a complete audit history of the event being resolved or at least identified. Now, responding to these events may take some system interaction. And one of the major questions that we often get about our platform is, can I run an execution on a host? Can I make a stateful change on a host? And the answer is no. We choose to not implement a control surface inside of CMD, primarily to separate duties. We're able to add controls and obviously our policies through our policy and trigger engine, but we also like to keep it very secure by not allowing you to run arbitrary executions that might clean up a specific command or modifying a specific action after the fact. It's really important to make sure that we're highlighting the events that you should go and act upon, and obviously maintaining state between the two. Now, all this sounds really amazing, and a lot of this is very exciting, but one of the things that we often get asked as a follow-up is, how quickly could I deploy this? One of the really interesting questions that I often get is to show some of these settings live. So rather than simply just show you some of the console, I thought I'd actually walk you through some of the properties of what we're able to achieve in a very short amount of time. Over here, I've just launched a couple of different hosts. I'm just using standard SSH key access, but as I mentioned, this could be pushed through something like Teleport's gravitational product. It could be a cloud native shell. It could even be something like AWS SSM running an exec on a remote host. I'll SSH into that host and we'll see that it's running. It's only been running for a short amount of time this morning, but one of the things that we want to be able to do is gain an understanding of what's going on within this server, within this system on our environment. It's really as simple as taking the host name for an arbitrary host, clicking add server, and we provide you an install script that's able to be deployed on the host with one single execution. This is not a super consistent way of deploying across your fleet. And a lot of people follow on to ask, can I automate this? And can I start to build this into my image process? You absolutely can. CMD comes along with a number of different policies that are built for industry standard deployment tools. And we often find our systems are built into either base or gold images, but it's one of those things that we have a couple of different options around doing. Once the agent's installed, it's really important to understand that once it's deployed, it's hooking. It's able to track any user interaction on the system. And then as a nice side added bonus, not only are we able to track this interaction, we're able to enforce a number of those policies I was speaking about previously. I'll highlight a couple of those policies today by actually looking at an existing web server within this environment. We can see that the agent's deployed on the host we've just deployed to, but I've logged into a system and there's a couple of interesting things about this session. We can see that I'm coming in from a relatively unusual location. We can see that I'm logging in with a shared account, and rather than just simply allowing the user to log into the system and potentially make a change, I think one of the things that's most important about kind of demonstrating shared account access is attribution. At CMD, we don't want to slow people down. It's not necessarily about blocking SSH. It's about asking why people are doing things. So in the shell, I'm able to interactively interact with that CMD agent. So in this case, rather than using duo, TOTP, or dual auth, I'm actually going to use a web auth token. This is just using a standard web request token, hitting our identity access provider, attributing the session to myself. In this case, I'm Jake, and I'm able to authorize that activity myself directly. Once that's acted upon, I'm able to access the system immediately and without any concerns. This direct access is done through a number of different methodologies, and we've shown that in WebAuth, but this could be easily tied into smart card authorization through your IDP. It could even go to your SSO provider to really simplify the process of authorizing the user's session. Now, why this becomes so interesting is as I start to type different execs, look at the different states of the system and run a couple of commands, not only are we able to see that I'm running those commands as Ubuntu, but in our sources tab here on our console, I'm able to view that session live. Viewing the session live is incredibly interesting, and it's often interesting for engineers that have very infrequent access to production. Any kind of access in CMD's production environment is deemed a little bit unusual, so we like to watch it closely. Our engineer gets a notification when a session starts live, and he's able to watch that session live. If there was a stateful change made, he's able to act upon changing that session state by stopping the session. He's also able to identify very quickly that it was Jake logging in, even though the execution user on the system was Ubuntu. And this unmasking is done through that authorization step up. What's very important here is to note that because we've simply reinstalled that agent incredibly quickly, we're also able to privilege escalate on the host. Now, this is really where a lot of the constraint and control comes into the platform. Sometimes we might not necessarily want to log in and authorize an account activity every single time. That would slow things down often too much for a lot of the kind of environments we're deployed into. If you're about to make an emergency change to a production system, you need to know that your engineers can have access quickly and efficiently. And so the policy of identifying that user through our authentication system here is only done when it's a shared account. It can be configured in a number of ways to authorize and authenticate, but in this case, I've been able to privilege escalate to root with very, very little interaction. Now let's look at a stateful change. I noticed that we used a host example in one of the previous commands. And so what I'll do here is I'll actually edit that etc hosts file again. I might actually just echo some extra lines into it. And in this case, what we'll do is we'll make that change. We'll see if we can action that option on the file. And rather than being just simply allowed to authorize that change, we're actually being presented with a question. Now, since we're able to map the user and identify who's logged into the system, not only were we able to determine that this user is probably doing the right thing, but making a stateful change to that etc hosts file to clear it out could be a kind of dangerous change in the system. In this case, I'm going to say, changing the hosts file. I'll press enter. I'll pop into Slack over here because I think this is a really important note to identify. Here, I'm monitoring this environment and watching it very closely. It's important that I'm able to identify who's logged into the system, the command that they're about to run, the session that they're actually in, so we can watch it live and see that change that's about to be made, but also being able to block that action in real time. Rather than simply denying the user the ability to modify that file through policy, having to go and manually deploy that entire fleet again, or even look into ways for that user to privilege escalate or try and get around the control, we've been able to demonstrate controlling a user's actions, even as a root account on a system, in a very quick way. That host file remains unchanged, and we're able to continue on with our day without that change being made. Now, if we were to make that file change again by simply appending a line to the file, which is not dangerous at all, we can, say, I'm trying again. And in this case, I'm immediately able to deny that action on the fly. This is a change that we really don't want to make. We do not want to see this file changed on our hosts. And in this case, not even as root, we're able to block an action in real time. Fundamentally, all of this comes back to our console. We're able to watch those commands live. We're also able to look at those alerts and those policies that have been firing live. So not only were we able to look at those DNS changes being made and the user's actions that were being fired, we're able to look at that session and highlight that event that was actually occurring, potentially even look at the file that was about to be changed. What's incredibly important about maintaining and monitoring these states, though, is, as I said, looking at those resolutions. We have the ability to resolve all of these in simple case management. We can say all okay, and now not only do we know that Jake's monitored that file, he's prevented production from being tampered with or potentially impacted, but we've been able to look at that exact behavior all and end to end. As part of that, we're able to look at our case management. We can see all of those events have been authorized. We can even look at existing alerts that have been run in the system. Going back in history, going back in time to see changes that were made to a particular system is often very handy in being able to identify what might have gone wrong. So in this case, we can see that a file was trying to be transferred and this contained key material. This was an incredibly, sensitive action. It's important that we look at these cases as being something that we might want to track alongside our security operations team. So not only can you see these in our console, but as I mentioned, these can all be forwarded to JIRA for existing ticket management. As we go through the platform though, it's really important to note that we can look at those very minute details, but seeing summary information about what's going on within an environment can often be incredibly useful. So once we've looked at different execs and perhaps even responded to some alerts, often our management team wants to understand what's going on within the environment that goes beyond just kind of looking at the detailed executions. We could look at, say, sudo usage summaries and see the total amount of commands. You can see there's a high volume of alerts in this environment as we do a lot of demonstrations, and we can see the commands that are being executed as sudo in a very quick way. We're able to dive deep into seeing who's run those executions and potentially even the volume of execs based on the time of day or the day of week. And these reports are entirely customizable and can be delivered to your inbox very, very easily. We try to keep this system very, very easy to use and quite standalone. But one of the components that I haven't really discussed is a number of those integrations that can be added to our triggers. So anytime we've gone through this behavior, anytime we've seen all of this detail, it's important to note that we can send all of this information to your S3 bucket of choice, or potentially even kind of forward and interact with different systems inside your environment. So that's been a quick look at the preview of the console. It's been a bit of a quick look at some of the patterns of behavior that we can see within this test environment, this demonstration environment. And we've demonstrated a few of the case management features of Cmd. What we haven't gone into today is a lot of the advanced controls that we can add to your environment. Being able to identify automated accounts, or potentially being able to create policies that block or change or even enact upon different system states within your environment. We also didn't really go into monitoring or maintaining any server states. This is really important to know. We can go into a lot of these details as we get into specific use cases, but I think one of the most powerful things about Cmd is that you can start from a very, very basic standpoint and really gain a lot of deep insights into your environment. So in summary, just to go back to what we were going to show in our demo, we showed a little bit of visibility and file execution. We demonstrated how we could do it safely. We showed how we could mandate some safe access and actually alert where it tends to matter, making a stateful change to a user's profile or a host's file. We're able to identify who changed that state, and in turn, we're able to respond effectively and in some cases, block that action automatically in real time. So we've run through a little bit of that demo. We'd love to give you the opportunity to check out the trial that we have online today. You can get us started as simple as by starting a free trial and actually running this in your production environment as we go. And you're able to start and accelerate your growth with CMD, not by adding those controls on day one, but growing with CMD and really understanding what's going on within your environment in really short order. So thank you so much.
All right, great. Let's go ahead and keep this slide on for a little bit so folks can take a look at that. But while we're doing that, let's go into the question and answer period of today's webinar. If you have a question for Jake, please go ahead and use your GoToWebinar control panel and submit it, and we'll go ahead and get started now. First question, Jake, how does CMD work with containers?
Sure. Containers operate in a very similar way to our host-based installer, and we have a number of ways to deploy our agent inside of containers. What we often find, though, is there's not a lot of human interaction with containers. So most of the time we're hooking services and potentially looking for those very unusual interactive shells. Any kind of interactivity with container environments tends to be a little unusual. And so deploying in a container with CMD is actually a really easy process. We have a lot of customers that do this through our automated deployment scripts. Some of them bake it into their container images. Others use it as a privilege mode on a container host.
All righty. Great. Okay, next question here. Let's see. How easy is it to deploy CMD across my cloud?
Sure. We can take that question from two angles. One of the most important things to consider here is CMD is cloud agnostic. We can be deployed in any cloud service provider, and we're often deployed automatically with different automation tools or kind of different package archives, or package deployment systems. We can be deployed across any cloud service provider. We can even be deployed in data centers. We have support for proxies and gateways and TLS kind of endpoints, and have the ability to do some really interesting controls for you if you do have a complex situation. But we have some very easy deployment methods that can be leveraged for cloud and obviously multi-cloud environments.
All right, great. Next question here is a multi-parter here. So the first one is does your agent have access root control on a kernel level?
So we have a number of different controls that we put in place on the system. We take advantage of a lot of kernel facilities to implement our control. However, we don't need to do any kind of deep kernel module or deep kernel module integrations. One of the questions that we often get asked is how we perform a lot of our controls. Using a number of the facilities of the linker, we're able to constrain and control different executions on the system. But it doesn't stop there. We leverage a number of the internal system controls inside of the SE Linux subsystem and a number of other subsystems on the host to make sure that we can constrain what a user can do effectively and efficiently without that kind of deep kernel module that's often used in security products today.
All right, great. The second part of the question is what access rights will the agent need to have?
So we run in different modes. We will hook and we will capture and we will prevent executions to the level in which you provide our agent permission to do so. Great question, because we often have the ability to tune and tweak the kind of level of the agent's operation inside of a container environment. Perhaps you're running a container as a non-standard user, a non-privileged user. We won't hook anything above the level that that container is privileged to do so. CMD typically runs obviously as a service on the system. That service is running in different privilege modes to gain a bit of access to those system calls that might be running as root. But we execute our agent and we hook all of this information as the level of permissions the user is actually running natively on the host.
Excellent. Okay, and the last part of this question, great question, by the way, Mario. Which country is your host service operating in, Canada or USA? Or
great question.
Somewhere else?
We have a number of deployment methods that either provide you direct service to our SaaS platform that is hosted in US West in Google Cloud. We do have the ability to deploy our solution in VPCs in multi-regions. And we have the ability to deploy that VPC solution really anywhere that Google Cloud's APIs are available. We tend to stick to the US and Canada, just given the kind of context of customers that we work with today. But we do have the ability to customize the data center for your needs as well if you have data sovereignty issues or concerns.
Excellent. All right. Plenty of time for questions. If you have one, go ahead and submit it via the GoToWebinar control panel. And we'll just keep plugging along here. Next question, can you put CMD on a gold image?
You sure can. Cmd can be operated or deployed into a base image for your systems. In fact, it's one of the most common methods of deployment that we see security software being deployed as. When security software is deployed across a fleet, you want to make sure that it's mandated, that you want to make sure it's deployed everywhere. So baking this into a gold image can be done very, very easily. The package that you saw me install through the one-liner script is simply just a Debian package. It's a very easy package to install manually as part of your kind of build process for your base image. And once it's deployed, you can change metadata about that system using hostname variables or system metadata. It's very easy to customize, the properties or attributes or parameters for that host. We also automatically detect a lot of this on launch. And the way we deploy our agent doesn't necessarily restrict you to a fixed amount of hosts. We have the ability to attenuate the way that we price the product through volume. So if you were to deploy a very diverse set of base images and have very low interaction, the price can be quite competitive, especially if you're baking it into every system you deploy within and across your environment.
Okay, great. All right, we have one more question here, but like I said before, there's still plenty of time. If you have a question for Jake, go ahead and use your GoToWebinar control panel. Let's see, the question is, how would you use CMD as part of your build and validation process?
This is a really interesting question. We're often seeing the product used on, pipelines, CI/CD pipelines that are hosted internally within organizations. In fact, we've got an interesting use case that we've seen for users actually looking for engineers that was shelling into a build server through basically the UI that was provided. Building CMD into your build or deploy pipeline can give you a good understanding of what that build pipeline is actually doing when it's rolling out or when it's deploying an application. It can give you an idea if it's running any of its installation processes or privileges as a privileged user. And it can also give you a bit of an understanding of exactly what's going on within that environment as that deployment's happening. So if you'd like to see, your CI/CD pipelines, outbound connections, for example, we have the ability to build reports and build visualizations around that. What it can also help with is understanding how that build process is being changed arbitrarily. What we've often found is CI/CD pipelines are pulling directly from Git. They're running a build, they're pushing an image into a Docker repository or into a cloud a kind of image hub. And what we've found is a lot of engineering teams monitor very closely that GitHub side of the code deploy process, but they don't monitor the CI/CD pipeline as closely. And since a lot of these pipelines are hosted internally, a lot of companies don't really want to trust that build process to a third party. Really gaining a bit of understanding into who is accessing that system, what they're doing and why they're doing it can be really valuable for understanding where things can go wrong. So we often find that CI/CD pipes are leveraging both outbound network connectivity, outbound execution activity, and obviously lateral movement. But we're also finding that arbitrary developer integrations and movements are quite interesting to look at.
All right, great. Okay, we just got another question in here. How is your agent secure the communicate? Oh, how does the agent secure the communication to your host service?
Absolutely, great question. We leverage TLS 1.2 with certificate pinning if you'd like to do that. We have the ability to not only encrypt the payloads that we're sending off the host, but you can choose what leaves the host. One of the really important things that I did actually bring up inside our demo was you choose the level of verbosity of information you'd like to send. Some of our customers only send metadata back to our service, so just the binaries, the base names, no output, no monitoring, no files, no tracking. Others choose to send everything that comes off that host. Once it hits that environment, it's encrypted at rest as soon as we collect it through our agent system. And the agent system is validated through individual agent keys, which allow us to attribute and identify the data that you are sending to our environment and check integrity along the way.
All right, great. So that is all the questions that we have right now, but I'm going to go ahead and leave it open for a couple more minutes to see if we get any more in. And while we're waiting, I do want to remind the audience that today's event has been recorded, so you'll be able to access the webinar later on demand if you want to, if you missed any or all of it, or if you just want to watch it again. We are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be on the DevOps.com website. So you can always go look for it there. Just go to DevOps.com/webinars and look in the on-demand section, and it will be right there waiting for you. All right, so no more questions in. So I am going to, I know at the top of the hour, I promised that we'd be doing a drawing for 3 $50 Amazon gift cards. So I'll be doing that real quick just to see if we get any more questions in after the drawing, then we'll go ahead and address them. But for now, let's do the drawing. The first of our 3 $50 Amazon gift card winners is David S. Congratulations, David. Our next winner is Donna H. Congratulations, Donna. And our third winner is Linda G. Congratulations, Linda. We'll be following up with you after the event via email to get your Amazon gift card delivered over to you so you can start spending and having fun with that money. So congratulations to all 3 of you. Well, Jake, it looks like we're not getting any more questions in. So I do want to thank the audience, those who did submit questions. Thank you very, very much. There's really great questions there. If you have a question for Jake, Jake, are you okay giving out your contact details to for any follow-up questions?
Yeah, there's absolutely the ability for anyone to send us directly an email. If you've got any inquiries around pricing for the product or any of the details for the platform itself, signing up for a free trial is a really great way to kind of get a bit of a preview of the product and actually understand how we price and package the product. If you've got any technical questions, more than happy to direct them to our engineering team, our sales engineering or our product engineering teams as we go. My email, as I kind of used in a few of the different points in the demonstration, is jk@cmd.com. So feel free to reach out to me directly. That's jk@cmd.com.
Awesome. All right. Thanks very much. And thank you for such a great presentation. I love to watch the demos. Lots of really good stuff.
Thanks so much. It's been great to demonstrate it today for everyone.
Awesome. Awesome. All right. I also want to thank the audience for joining me today. I'm going to give you 8 minutes back in your day. So this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.